discussed about. All right, welcome to today's lesson. My name is Kabir. In our previous lesson, we actually discussed about measurement and units, where we discussed the major instruments used for measuring distance and length. So today we're going to discuss about position, distance, and displacement. All right, so let's go straight to the objective of the lesson. So by the end of the lesson today, we're supposed to be able to define position, distance, and displacement, and we're supposed to be able to carry out some simple calculation involving this distance and also displacement as well. So what is position? Position is actually a point in space, okay? And is determined by its distance and direction from other points. So in a nutshell, we can simply say position is the space between 2 points, or we can say position is where an object is located. So the position of an object is actually told with the things surrounding the position or that particular object. So if, for example, we have a cup on a table, if we want to tell the position of that cup, we said the cup is on the table. So the table is now a reference point. It's a reference point to the cup. So what if the objects used to tell the position of an object are referred to what? A reference point. And today we're going to use what we call Cartesian plane to represent the point of objects. Now, let's see how we can do this. We have an example here that says a point A has the following coordinates: 2, minus 3, and has the value, and x has the value of 2, and y has the value of minus 3. So if we are going to represent this on a Cartesian plane, we're going to have this. So let's draw the Cartesian plane. So first we draw a straight line. Okay, now this straight line here represents our y-axis. Then we draw another line, and this line here represents our x-axis. So then this is the origin where the line meets. Then we can have our coordinates plotted. This should be 1, 2, and we can go 1, 2, let's say 3. So we can actually number this now. Let's say this is 1 and 2. Then this is also 1, 2, 3. So the negative side of the y will be minus 1 and minus 2. Then here can be minus 3. So if we were to plot this point, this here, the first number in the coordinate is actually the x abscissa is called abscissa, y that of y is called coordinate. So this will be our x1 and y1. So we can pick out our points by simply tracing x and y. So this is x2 here. This is y2, and sorry, this is y2. This is y minus 3. Now this is y positive 2, and this is x positive 2. So we go y minus 3 here and x plus 2. So we can represent this and make our points here. represent our x. So this point is, and it is equal to 2, minus 3. So haven't seen this. This is called the Cartesian plane, where you plot your coordinates. Now let's quickly, because of time factor, let's quickly jump into defining what distance is. Distance is defined as the length of space covered by an object. Okay, we can say distance is the space between 2 points. And also, we can also say that distance is the product of average speed and time. Mathematically, you can say distance is equal to average speed times time. And the SI unit for distance is meters. Remember, in our previous class, we actually look at the fundamental quantities and also derived quantities, where we say that length is measured in meters, and which is simply the space between 2 points. Now, before we solve simple calculations using length and displacement, let's see what displacement is all about. Now, displacement is the distance traveled in a specified direction. That's just the difference between distance and displacement. Distance is a scalar quantity in this sense because it has magnitude but has no direction, while displacement has a specified direction at which it travels. So we can quantify this as that displacement is a vector quantity, while distance is a scalar quantity. And displacement is denoted with letter S because it has both magnitude and direction, and the SI unit of displacement is still meters. Now let's see an example here. The example says, a man walks 1 kilometer due east and then 1 kilometer due north. We should find the displacement. Just the way we plotted out our point earlier, the first thing we need to do is we need to draw our Cartesian coordinates. So we can go like this. We draw it out. So this is going to be our north. This is our east. And also this is going to be our south. And this is going to be our west. So according to the question that the man traveled 1 kilometer due east. So we can decide to say this here is our 1 kilometer. So he got to this point, then he traveled 1 kilometer due north. So this is 1. And for us to find the displacement of the man, we were going to make a triangle out of this. So if we make a triangle out of this, then we can easily calculate the distance traveled by the man. So let's do that. We're going to use Pythagoras theory to calculate for this. So we're just going to represent this part of the hypotenuse of which is the magnitude of the distance traveled. So we'll say, remember, according to Pythagoras theory, the sum of the opposite the sum of the square of the opposite and square of the adjacent is equal to the square of the hypotenuse. So we're going to have R is equal to, so we have 1 squared and plus 1 squared. So if we do this without wasting time, so if we're looking for R alone, So one square is one. One square is also one. So that's 1 plus 1 is 2. So to find R, we're going to find the square root of 2. So if you look at the angle formed here is 45 degrees. So we can see the displacement S is equal to root 245 degrees north. So we can see that it's root 245 degrees north. So let's quickly look at this. This says calculate the distance in meters covered by a body moving with a uniform speed of 180 kilometers per hour in 30 seconds. So this is easy. Before we do this, we just simply going to take out our parameters. We're given that speed is equal to 180 kilometers per hour. And we're also giving time, T, to be equal to 30 seconds. So the next thing we want to do is we want to convert, we're going to convert speed to its fundamental unit, because kilometer per hour is a derived unit for measuring time. So to do that, we're going to have a conversion. So conversion here, we're going to have this will be equal to 180. The kilo there is standing for 1,000. So 180 times 1,000 meters divided by, we have 60 minutes in 1 hour, and we have 60 seconds as well. So it's going to be 60 times 60. So if you do this math, you're going to have that all of this is equal to 50 meters per second. So that is what you're going to have speed to be. So our speed will be equal to 50 meters per second. Then we can now quickly substitute for, the value for speed in our equation. So we already know that displacement S is equal to, we already know that displacement or distance S is equal to speed times time. Displacement is equal to speed times time. So if we substitute our value, this will be equal to 50 meters per second. 50 meters per second times 30 seconds, as given in the question. 30 seconds, and this will be equal to, if you multiply 30 by 50, you're going to have 1,500 meters. So that is that for it. So the next thing we're going to look at is the distance between two coordinate points. So the distance between two coordinate points can be calculated using this method. How do you do that? In this case, we have point P and a point Q on the Cartesian plane, Y and X, point P and a point Q. Now, this point Q has this coordinate x2 and y2. Y point P here has the coordinate x1 and x2. So for us to be able to solve this, or to actually calculate the distance d here, we have to use what we call the Pythagorean theory. As stated earlier, we said Pythagorean theory states that the square of the hypotenuse is equal to the sum of the square of adjacent and opposite. So for us to calculate this, we'll have d, which is small letter d there, will be equal to d will be equal to, sorry, d square d will be d square. Sorry, let me just this. Let me try instead. So we're going to have d square will be equal to PR square plus RQ square. So so if we do this, we're going to have d is equal to d will be equal to the square root of PR square and RQ square. Now, to make this easy, we'll just go, this is equal to the square root of S2 minus X1 square plus Y2 minus Y1 square. So with this, you'll be able to calculate for the distance between 2 points. So just like we have an example here, the example says we should calculate, or we should find the distance between 2 points, 2 coordinates, which is A, which is 3, 2, and point B, which is 6, 8, and 4, sorry, I beg your pardon. So to solve this problem, we're going to use the distance equation that we got earlier. So we're going to have D is equal to, and don't forget, this is our X1 and this is our Y1. So this will be our X2, this will be our Y2. So we're going to have square root of here we're going to have our x2 is 6. So open bracket. We have 6 minus x1 is 3. 6 minus 3. This is square plus our y2 is 4 minus y1 is 2. Don't forget to square it. So this is going to give us, we have 6 minus 3 will give us 6 square plus 4 minus 2 will give us 2 square. So if we quickly do this, c square will give us 36 plus 2 square will give us 4.
Excuse me, sir.
Yes.
Excuse me, sir. He said
Yes, I can hear you.
6
Oh, sorry. I can't hear you, but I get your
Sir,
correction
can you
now.
hear me?
Sorry. Yeah, I can hear you now. Thank you for that correction. 6 minus 3 is 3. So this is supposed to give us 9. Okay. I sincerely apologize for that. So 3 square will give us 9. So this will give us the square root of 9 plus 4 will give us 13. So if we find the square root of 13, if we find the square root of 13, we're going to get all right. So are we still together?
Yes, sir.
Can anyone hear me?
Yes.
Okay, sorry, I'm having a glitch on from my end here. If you find the square root of 13, you'll get your final answer. So I don't have a scientific calculator here. All right, just hold on. Okay, if we find the square root of 13, we're going to get 3.6 units. So we're going to get 3.6 units, and that is the distance between the points. So at this point, do anyone have a question? Any question? Are we together? Hello? Hello?
Hi.
Okay, can you hear me? I said, is there any question before we proceed?
Hi.
Any question? Any questions so far? Hello? Okay, let me quickly take it again. We started by defining what position is, and we'll say position is actually a place where an object is located, and that's what we'll say position is. And we also say that distance is actually the space between 2 points, and to calculate or to tell the position of an object, we said that the position of an object is set with a reference frame or a reference system where you use to explain the position of that object. If you're to say there is a table, there is a cup on the table, you say, okay, a cup on the table. So the table becomes the reference frame for the cup. And also, we're able to use the Cartesian plane, which is the x and y axis, to tell the location of a point on the scale. Then we also mention that displacement is simply distance in a specified direction, and it's a vector quantity because it has both magnitude and displacement, both magnitude and direction, sorry. Then we're able to solve an example here that says a man walks 1 kilometer due east and then 1 kilometer due north. And we're asked to find the displacement, and which we did. So we were also able to calculate for the distance between 2 coordinate points as well too. So please, do anyone have any question about what we've done so far? We just have 9 minutes left. Hello? Hello, can you hear me? Can you hear me?
Yes, I'm sure they can hear you. Just continue with the class since they are not answering you.
I'm actually done here. So that's what I'm trying to.
Oh, okay.
Yes. So I can stop sharing now. And